So basically, EMI can induce a few problems. For example, bit corruption, which is associated with digital devices. For example, artifact changes by value, which is usually can be fixed with error detection scheme. Secondly, EMI can induce problem of junction rectifications, which is associated with analog devices. So in which high frequency AC produces DC at semiconductor junction and produces DC offset voltage or modulated signal. All right. Now after this, we're going to look a few example of EMC and EMI problems that occurred in the real life, right? For example, we look the first case of ABS failure. So early anti-lock braking system, known as ABS system on both aircraft and automobiles like car and lorry were susceptible to electromagnetic interference. So what happened? Eh? When this ABS failed to withstand the EMI, so normally accident occurred when the brakes function improperly because of the EMI disrupted the ABS control system. So this is very important now. If you imagine that, if you bring your smartphone or handphone into your car, and if your ABS system cannot withstand the EMI produced by your handphone, so it might cause your ABS fail to function. So nowadays, because of the improvement in the technology, then your ABS can be function normally, even with the existing EMI from your medical device. So that it is very important to design a smartphone or handphone which is EMC and also EMI, same as with your ABS car system. It must be having a good EMC, and at the same time, it must also have a good EMI, so that it can be working normally in the EMI environment. So the second example is the tragedy or the accident involving the runaway wheelchairs. And some of wheelchairs experience erratic, unintentional movement when police or fire transmitter were activated nearby. So this is very quite very dangerous now. So you cannot control the movement of the powered wheelchairs. So this movement included sudden start that caused wheelchairs to drive off curbs or piers. So although no fatal injuries have been reported, Food and Drug Administration has ordered manufacturers of motorized wheelchairs to shield them from EMI and to educate users on the potential hazard. On the potential EMI hazard. So this is also quite dangerous now. So we need to shield the system so that it will not interfere when the police or fire transmitter were activated on that areas. And the second case involving ambulance heart monitor. So susceptibility of medical equipment to conduct aurated emission is a concern. And so the case, a heart attack victim was being taken to hospital with a monitor or defibrillator attached to the patient. But every time the personnel turned on the radio to request medical advice, so the machine shut down and the patient died. So this is very serious. This is a very serious case. Also, from the investigation, it has found that the cause of the shutdown of the machine is because of the combination of insufficient immunity of monitor or defibrillator and excessive radio frequency field strength from the radio. And the ambulance roof had been changed from metal to fiberglass. So this is the action lah. So one of the technique is replacing the ambulance roof material from metal to fiberglass. So this is very critical things now. So that you need to design the medical life support device is having good immunity of the interference, so that we can ensure that the continuity of the medical device to support the life of the patient when bring the patient in the ambulance, especially. All right, the third case is about the Black Horse crashes. So between 1981 and 1987, so 5 Black Hole Army helicopters crashed and killed or injured all on board when flew too near radio broadcast transmitter, right? So from the investigation, it has found that it is insufficient immunity of flight on board control electronic subsystem against high intensity radiated field, HIRF, that produce uncommanded movement while flying past radio broadcast. So lose control when the helicopter is flying near to the radio broadcast transmitter. So this is also very serious accident or incidents. Okay. All right. So the last case is involving the hearing aids. Hearing aids mentioned in the picture. All right. So millions of pensioners using a hearing aid device were forced to endure 24-hour rap and rock music from the 41 powerful radio transmitter of Airing Radio 1 network in the UK. So from the investigation, it has found that the cause of this incident is due to by a flaw in the device that acted as an intended radio receiver. So this hearing aid is functioning as an intended radio receiver. In addition to its intended function, the intervention is to help the patient to hear, but at the same time, it want to the device is helping the user to hear, and at the same time it is also functioning as a radio receiver. So it has to function at the same time, and because of the electronic interference from the radio transmitter. Right, so this is one of the things that we need to avoid. All right, so there are a few things or methods that can use to confirm the electromagnetic compatibility of a device. Right? Okay, now we look. The first one, to reduce the interference, the acceptable limits for emission, immunity and coupling must be observed when device operate. So this must be observed throughout the entire life cycle of the device, starting from the design, make, install, upgrade, and also during the maintenance phases. So in order to ensure the compliance to EMC for this device, so the device must be tested using proper test method for each type of connection, which is what, and also the electromagnetic phenomenon. For example, radiated EMI, conducted EMI, or electrostatic discharge test, and etc. All right. So now we look at the EMC limits, right? So basically we have emission limit and also we have immunity limits. So emission limit is the maximum disturbance level which the equipment is allowed to produce, right? So meaning that there is certain limits of electromagnetic uh, exposure that can the medical device can expose. And then we have the immunity limit, which is the minimum disturbance level which the equipment should withstand and without its operation being unacceptably degraded. So the immunity and also the emission. Emission in terms of the EMC that is produced by the medical device, whereas the immunity is the ability, the minimum ability of uh, the minimum disturbance level at that specific medical device can withstand uh, without causing any disturbance or interruption on the function and system of the medical device. All right. Now we look at the system environment. So the first one, we need to test we'll separate the system from its environment. So we have to separate the medical device from the environment. And then after that, the second one, which is the emission testing. So we place the environment by test equipment that evaluate the level of emission. And the third one, so immunity. So we create a known electromagnetic stress and observe the reaction of the medical device. Right. So these are the thing that the the techniques on how to evaluate so the emission level and also the immunity level of the medical device. All right. So the first one, we need to separate the the medical device with its environment. After that, we need to test the emission testing and by replace the environment by test equipment. And so the test equipment will evaluate the level of emissions. And the third one, in immunity test, we create known EM stresses and observe duration of the medical device. So these are the example for the test room. In order to evaluate the the EMI and also the EMC. So we can create the environment for that medical device. So if we want to expose the medical device with the high density EMI interference, then we can create that condition to test the immunity level of the medical device. Right? And then if you want to test the EMI exposure, then we can put that medical device and then we put uh, the testing device, and after that we can analyze the exposure level, the exposure level or EMC of that device. So basically this is the radiated emission limits and also the RF immunity fields in residential and for industrial area, right? So for residential, we have a 100 to 500 microvolt per meter, which is class B. Whereas for industrial, is 300 to 700 microvolt per meter for class A. This is for rated emission limits. Whereas for the RF immunity fields, for residential is 3 volt per meter, whereas for industrial is 10 volt per meter.